Okay, good morning, students of 13 Calculus. I'm going to show you this morning how to integrate functions that look like this, where you've got an x on the bottom and a 1 on the top, like 1 over x. And they're very simple because we've already learned that if we have a function in x which is of the form the natural log of x, that when we differentiate this natural log of x, we get 1 over x. So in other words, if we're going to be integrating a function like 1 over x, it's going to go back to this natural log of x. Okay? And that's what I've written down here. So integrating 1 over x is very easy. It gives the natural log of x. So we write it like that. But we have to be a wee bit careful because you can't have the natural logs of negative numbers. You can't have the natural log of -1, for example. They don't exist. So we have to, when we integrate 1 over x, we have to ensure we mean that the answers involve the natural log of the positive numbers. And we do that by writing these two vertical lines either side of the x. They really mean the absolute value of x. In other words, the absolute value means just the value without a positive or negative sign. Okay, so just remember that. That's a very important little step. All right, let's have an example. Now, in this example here, I've made it rather hard to start with, but I'm hoping if I can explain it clearly, you'll see exactly what the little tricks are. And they are little tricks, but you've got to know them. You've got to practice them. So imagine you've got to integrate this thing here. And by the way, this thing to be integrated, this 6 over 3x plus 2, this thing here, it's got a very special name. It's called the integrand. Okay, I've written that down somewhere else, and you'll see that later on. But this is the integrand, and it's to be integrated. Well, the first thing you do is this 6 on the top is like a constant, and you can bring that constant outside the integral sign. So really what you're integrating is 1 over 3x plus 2. Well, you can see immediately that that's getting very close to this 1 over something to be integrated. And what we do is this. We let this 3x plus 2 be equal to u, or you let u equals 3x plus 2. Now, if you differentiate this, what you're doing, you're saying du by dx. Well, if you differentiate that, you get du by dx is 3. Now what you can do is you can cross multiply this dx here up there with the 3, so that you've got a connection now between du, this variable u, and dx. So in other words, if I multiplied dx by 3, it actually stands for du. So that's what you do in the integral. You multiply the dx by 3. Okay? Now, you then have just multiplied the entire integral by 3. But you've got to keep the integral the same. It's got to stay the same thing, the same value. So in other words, when you multiply the dx by 3, you've got to divide it by 3 at the same time, because those 3's would cancel. So it's the same as that thing over there. Okay? Hasn't changed because you've divided by 3 and you've multiplied by 3. Well, that division by 3, you can bring it out underneath the 6 there. That is going to go down to 2 later on. But look what you've got left. You have got 3 dx, which is du, and you said over here that u is the 3x plus 2. So this 3x plus 2 in the denominator you can replace with the u. Now look at what you've got to integrate. You've got to integrate something much simpler. 1 over u du. And that, of course, is the natural log of u plus the constant of integration. Well, what did we call u? We called u 3x plus 2. So you put that in between these vertical lines here, meaning we only take the positive values here, and we add the constant of integration. And of course, the 6 divided by 3 is 2. So all of this, where has it gone? All of this here integrated gives the answer 2 times the natural log of the absolute value of 3x plus 2, all plus a constant. Okay, now I'm going to see if I can find the next page that's got examples on it. Is it the next one? Yes, there it is. Okay, I'll just zoom in so we can talk our way through this one as well. There we are. Just increase the size of the page, I think. Let's see. Oh, yeah, okay. All right, so we're going to go through example 2. Yeah, so there it is. You've got to integrate this ferocious looking thing here. Look at it. Oh, I'm going to kill you. No, it's not. It's easy. It's easy. All you got to do is simplify it first. You put everything over the same denominator because everything, this whole numerator has been divided by that x. So what you do is you split it up so each part is being divided by x. And of course, when you do this, this x is going to cancel with one of these. So this is going to go down to x to the power 4. This x is going to cancel with that one. It's going to go down to just 4x. And then we have this 3 over x left at the end. Now that we've got this like this, we can integrate each part. So here we increase the power of the x by 1 and divide by the new power. There it is, x to the power 5 over 5. The 7 remains untouched. The 4 integrated, 4x I mean, integrated, goes 4x squared over 2. The 2 will now cancel into the 4 to go just 2x squared. But here is what we've been looking for. The 3, of course, remains untouched by the integration, but we're really integrating here 1 over x. So it's going to be 3, the natural log of the absolute value of x, plus the constant of integration. So that ferocious looking thing integrated is finally this thing here, 7x to the power 5 over 5 minus 2x squared plus 3, the natural log of the absolute value of x plus c. Fairly straightforward, guys, when you can do it. Now let's have a look at this thing here. Well, again, this thing here is very straightforward when you've done a few little tricks. And I'm showing you this trick because this is very important when it comes to slightly more complicated integrations. So I think it's good for you to learn these little tricks now. Well, the first thing you need to do is to move this 4 outside the integral sign. There. What have we got left? Well, we've got 1 over 3 minus 5x. Well, again, this is very close to this 1 over something, and we have to let u equal this denominator. So that's what I've done there. Let u equal 3 minus 5x. So if we differentiate, we get minus 5. So du by dx is minus 5. Now, if I cross multiply the dx up here, I get a connection. I can see how this variable u is connected to the variable x if I write minus 5 times dx. So in other words, if I go back to my original integral and I multiply this dx by minus 5, then that's going to be du. But I can't multiply the integral by minus 5 if it changes the integral. So to keep the integral exactly the same value that it was at the beginning, I've got to divide by minus 5 at the same time as I multiply by minus 5. So that those two, minus 5 divided by minus 5 is just plus 1. So I haven't changed the integral. But this minus 5 can now be brought forward underneath the 4. Okay? And because minus 5 dx is really du, I can now integrate with respect to the variable u, du. The 3 minus 5x I said was u, so you replace it there. There it is, there's the u, replacing the 3 minus 5x. Now, of course, this is super easy. It's just the natural log of u. Okay, so you can do that, and you can then replace the u with the original function of 3 minus 5x, but it's now minus 4/5 the natural log of the absolute value of 3 minus 5x plus c. Now, I haven't given you any exercises to do with this. They're going to be coming in a next not the next video, but the last video. I'm going to put some exercises together that include all these things that you are about to be learning on, some of the things you have already learned in integration. All right, thank you very much.